in deep learning today, which is image recognition. Okay. So imagine this scenario. You are entering a building and you are an employee of the organization. Okay. So this automatic entry machine contains a camera. Okay. And this camera looks at the picture, clicks the picture, the complete person, and the surroundings also. Right. Then, in order to recognize you, the data is sent, the image is sent to uh, the processing engine. And in order to recognize you, you have to focus only on the faces of the person who is coming in, right? So from the whole image, how do I understand that, okay, this part of the image is the face. Okay, this part is hand, this part is, let's say, hair or legs. How do I understand that? So to do this, we use the technology known as image or object detection. And the number one library everyone uses to do this is OpenCV, Open Computer Vision. So what it helps us, object detection, or in this scenario, face detection. Okay, so I have an image. From that image, I want to understand that, okay, this particular portion of the image is face. So detection of the face. How do I know that? So maybe face has a general structure, oval structure. Then you will see two circles, one kind of triangular structure, the nose, and then one semicircle, or maybe not always semicircle. So kind of structure. Then you have one kind of ellipse over here, one ellipse over here. You see all of these mathematical forms is nothing but makes a face, and you can go on and on and on and describe more features of a face to accurately identify in any given picture. You can identify the face. Okay, so these are rules written by OpenCV models. These are known as Haar cascades. So these are rules for all sorts of objects that you want to detect. Like you want to detect a face, you want to detect eyes, nose, you want to detect hands or other objects. Let's say you want to detect a traffic light, you want to detect a tree or a truck or a sign, etc., etc. So there are different kinds of objects and each object has its characteristic. So based on the characteristics, I can write a rule that if a traffic light is there, then it has to be a long structure. Then at the end of it, you will see some things that are blinking or, circular structure or rectangular structure. If it is a truck and you're looking at it from the behind, then it will look like a rectangle and then there'll be a closing door. You might identify two tires within it. If you look at a car from behind, it will look like probably a trapezium, so on and so forth. So there are multiple structures, multiple characteristics for every object that is out there. Okay, starting from tree to flower to everything. So you can detect these kind of rules using OpenCV, Open Computer Vision, using these rules stored there as Haar cascades. Okay, so this is the first part, that detecting that the object is there. Then the second part is to recognize what object is there. Like if I see a truck, whether this truck belongs to Tata, whether this truck is from Mercedes, whether this is Ashok Leland, what is that? So which company's truck is it? If I detect a car, is it a Tesla or is it a Maruti or is it a Ford? What type of car is it? This is called recognition. So for object detection or face detection, we use OpenCV. For object recognition or face recognition, in general, you can say image recognition. You use convolutional neural networks, CNNs.